Welcome back to this course, Introduction to Cybersecurity. This is a presentation of coding boot camps. Our lesson here is Introduction to Cryptography, how cryptography works. So our topics here are Introduction to Cryptography, encrypting algorithms, and how various cryptographic algorithms work. So just a recap of what we learned so far. We went over why we needed cybersecurity, the types of attacks, what is cybersecurity, the CIA Triad, and how cybersecurity is implemented. Well, right here is a good example of why cybersecurity is important. You can see here Andy and Sam are communicating over a network, probably sending just clear text to one another, unencrypted text. Problem is you don't know who else is listening. So Sam and Andy think they're communicating directly with one another. However, as we can see here, Eves has come onto the network. He's intercepting the message that Andy thinks he's sending to Sam, changing the message and saying, Sam, would you lend me $100? And it looks like Sam is actually complying, but it's probably going to be $100 that goes back to Eves. So this is why it's important to make sure that only the intended party can read your messages or gets the messages, and that we encrypt and make it impossible for any third party or malicious third parties to read our messages. We can see here a little bit about the introduction to cryptography. We have a message here. You can see it's a numeric message, 1034259. We encrypt it. It becomes what we call ciphered. It goes out publicly. The cipher is meaningless to any third parties or other parties out on the public web. We decrypt it, or there's an error delivered. So if somebody tries to read this message, and tries to decrypt it, it's better that they get an error than they actually get our message. Here's another example here where Andy is using encryption, so is able to take this message, encrypt it here to this cipher, and Eves is somehow managed to alter the message. However, we notice the cipher here ends in 3001, and even though he's managed to alter it, the cipher is now 3004. What happens when Sam tries to decrypt it, he'll at least get an error. He's not going to get a fraudulent message, which is better than what we had before. So cryptography here is a brief hierarchy of cryptography. There is symmetric key cryptography, where the same key is used to encrypt as it is to decrypt. Asymmetric key cryptography involves two keys. Classical cryptography involves transposition ciphers and substitution ciphers, whereas modern cryptography involves stream ciphers and block ciphers. So how various cryptographic algorithms work. Before we go any further, let's take a little break, pause this video. Okay, let's continue. So we can see here with symmetric cryptography, there's plain text, which is a readable message for anyone. It's signed with a key, and there are various ways that this message can be encrypted. However, this is the key that's used. This is now the cipher text that comes out. Anybody with the key can decrypt it and convert it back to that plain text. So this is all the same key. So if there could be a key similar to, in the alphabet, maybe we switch the position of the letters 1. So every time there's an A, we make it a B. Every time there's a C, we make it a D. So that way, anybody who has that secret key knows when they see a B to convert it to an A, and anytime there's a C to convert it to a B. That would be an example of the symmetric key cryptography. Also, we see these transposition characters, so we can see here this message, meet me after the party, or meet me after party. We can see here that it is these are the positions right now, and then it's ciphered, the key used here is ciphered as this right here, 421635, which gives us this. Now, what we need is for transposition somebody to know what position to convert it back to, and they'll be able to read the message. This is an example of substitution ciphers. So we see the zebras keyword. So we can see here there is a substitution using zebras right here, and it converts this message here, flee it once we are discovered, and enciphers it to what we have right here. A stream cipher, there is a bit stream. We can see here is M, and the a pseudonym byte generator creates a cipher for us, and it becomes a C. And then there is a pseudonym byte generator here that does the decryption and converts it back to M. A block cipher here, we can see there was plain text, the block cipher, and now we have our encryption here. Now we have our cipher, and the cipher is read here by the block cipher decryption, and it's converted back to plain text. We have our RSA algorithm. Here where there are two large prime numbers, and it's used to compute here a cipher. The numbers E, we can see here, such that E is less than N, which has no common factor other than 1 with Z. We can see the mathematical encryption here. Keys are generated. There is a public key and a private key, but they're both generated at the same time from the same mathematical calculation. We have our encryption here, C equals M to the E, and M is plain text and C is the ciphered text. So here we have our C. And then our decryption here, we'll use that C and convert it back. So with this type of cryptographic algorithm, there are two keys. The public key is shared, and that's what's used to encrypt the message. But only the person with the private key, the intended party, can decrypt the message. Here again, an example of the asymmetric key encryption or public key encryption. We have plain text here. A public key that everybody knows about is used, similar to a mailbox or an address, is used to encrypt the message. It becomes ciphertext. However, only the intended party has the private key, which can decrypt the message. So what we've learned so far, we learned our introduction to cryptography, encryption algorithms, how various cryptographic algorithms work. And our follow-up session, what is computer security threats, and best computer security practices. Again, our follow-on sessions again, introduction to the Linux operating system, blockchain cybersecurity, and Python programming. Please consult your learning materials. Thank you for watching this video, and stay tuned for more videos.